Alright, this video is going to cover some tire tread modeling challenge kind of tips. So in the tread modeling challenge, we've identified the Kumho Road Venture ATKL 78 tire to model. And in this, I've done the research a little bit for you. I've kind of figured out the diameter of the tire is 30.5 inches, the width of the tread is 7.2 inches, the depth is 13/32 of an inch. So I'm going to sort of show you how you can sort of take that and work that into creating the dimensions of the tire as it relates into 3ds Max. If you're using other programs, you'll just have to sort of make that conversion and figure out how to do it in the other programs. So we know that the tire is going to be 30 inches 0.5 for the diameter. So what we can do is we can create a basic tube for the tire, and depending on how crazy you want to get with it. And I also know that it's 7.2 inches wide, so sometimes I like to create a plane that kind of matches those dimensions. So if I know it's going to be, let's see, it's modeled from the we'll do it that way. 7.2 inches. Now Max is set up by default to work in inches, so I don't need to do anything, but I can also just type in 7.2 and then put the quotes in there that signify inches, and it will translate that into whatever units I'm currently working at inside of 3ds Max. So that's the width of the tread, and I'm just going to create a cylinder. Turn my angle snap on, snap at 90 degrees, and I'm going to do, my radius needs to be half of the diameter, which 30.5. So I'm going to hit Control N inside my radius, and I'm just going to do 30.5. And this expression evaluator is really kind of like a built-in calculator that lets me do some basic calculations. So I'll do a /2 to divide 30.5 into 2 and paste the results into the radius. So this is kind of the size of the overall tire. So using this as a width and this for my overall sense of the tire, I can kind of start to work from that. The other thing that we've got is we've also got tread depth. So the tread is 13/32 of an inch. So what I'm going to do is I'm just going to create a box, and this height, I'm actually going to do that expression again, Control N, and take, what was it, 13? Was it 13? 13/32. And so 13 divided by 32 is 0.406 inches. So that's the thickness of my tread. So thereabouts. So I'm going to go to my left view and kind of look at my overall kind of tire. And what I can do is I can create a bare, a bald tire, so to speak, that minus the width of the tread piece in here, to give me a base tire. And I know my thickness. I'm actually going to make this box the same width as the plane, just so I can use that as well. So that was 7.2. So we'll make the length 7.2. So now I've kind of got both of those factored into the box. And what I'm going to do is I'm just going to kind of build out just a quick, oops, come on, shape here that lets me. There we go. And I'm going to refine the shape. Really probably should just work on one side and mirror it over, but it's okay. Should be a fillet in here. Just I'm not. The challenge is not to model an accurate kind of sidewall. We just want to make sure we get the tread shape kind of modeled to match that. If you want to spend a little more time trying to figure out how the sidewall should look, you can. It's just a little hard to, because the reference isn't going to be all that great for doing that. So let's just take that in a little bit. It should be a little. And depending on the rim, I'm not too worried about the rim size, but I think I don't know if the diameter of the wheel is 22 inches. You could do another cylinder or something to figure out where the wheel would set, but again, this challenge is really not about that. So there's just a basic shape of cross section of the tire, and I'm just going to use the lathe tool. Pick the proper axes, and you can see how it's lathing correctly, but not to the right size. So before I do this, I probably need to I just need to do some alignment stuff. So I'm going to align this shape to here. And I'm going to target the maximum. I'll just center it first. So I'm going to center it to the object. Then I'm going to take the shape and I'm going to actually align it to the top of the tire. So I'm going to take the. Let's see if I can do this. The maximum, is it going to let me do that? Maybe it's not. It's not going to let me pick. Well, I can just manually bring that shape up. And because it's not moving the pivot will stay with the object. Like so. So now the pivot's centered to my my base tire reference, and now if I go back and do my lathe, it will use that pivot center so that my tire is the right size. Now again, it's going to be a little smaller because the tread's going to come in and fill this part in my tire. And if I increase this to 64, sort of smooth that out. So there's my kind of base tire. And again, I could go back into the stack and refine this shape, add ribbing if there's little rib pieces to the tire. Make it fancier if I wanted to. But as far as a base tire, it'll do fairly well. So there is my sort of to scale base tire, and this is kind of where when I get into modeling the tread, I'd bring in a plane, map it with the reference of the tire tread. But one of the things I like to do is I like to set this reference plane to figure out how long that tread needs to be that I need to model it here before I bend it and wrap it around. So I know that the diameter is 30.5, and I like to use a handy calculator for this. And I got it somewhere. It'll be in the there'll be a link to it in the PDF here. So there'll be a website that will do this calculation conversion for you. So if you know the diameter, which we do, which is 30.5, you can have it solve the others. So we know that the circumference of this tire is 95.82-ish. Okay, so I can take this number, copy it, and now this length, or in this case the width of this plane, would be that converted number, and it's going to sort of round it out, so 0.819. So that distance is how long the tread needs to be, so that when I go ahead and bend it, it will wrap around and be the size that it needs to be for the tire. Now right now the segments are set to default 4x4. Another thing that I like to do is I like to look at my reference and figure out how many times that tread pattern repeats. So if I go to the and kind of review one of the images, let's just take this. So what I'll do is I'll actually count how many times this repeats, and there's actually a nice little element to the tire that actually matches up with the tread. So you could count like this side piece and count all the way around. I would just sort of count these pieces. So I could go 1, 2, 3, 4, 5, 6. I'm just going to say there's 62 of them. I didn't actually count them. When you go to model it, you'll actually have to make sure you figure out how many there are. But for this, I'm gonna use a number. So if there's 62 repetitions, tread segments, I'm actually going to put that in my reference here. I'm actually going to set this to 62. So now I have 62 sections, so I know exactly how big one section of treads needs to be so that it's sort of accurate to the model. So that when I get in here and actually start to model this, and usually what I do is I center this to the 0. I just move my object right to the middle, which tends to work out pretty well when I get into modeling it. So now I can work from this as a base and kind of build out my shapes. So if I start with a plane, so if I'm building my tread piece, and I'm just doing something really quick. It's not anything like what the actual tire is. When I go to figure out how to make this sort of repeat, I'm just going to give it some dimension here. Take these, isolate this. Now what I can do is I can actually create an instance of this. Oops. Just want the tread piece. And I do want, I should add a point. It's kind of helpful to have a vertex in there. So I'm going to set my pivot. I'm going to right click in my numbers here to reset my pivot to 0, 0, 0. Again, that's another reason why I set my reference plane to 0, 0, 0. So that I can snap and set my snaps so that I can snap to the pivot and to the vertex. So when I go ahead and hold down the shift key, I can snap directly to this other segment. I'll do this as an instance. So now, I can you need to kind of make sure that the gap between these is the right size. So if you make one copy an instance, then you can go to either one, start making your adjustments, and you can sort of see how that's going to how your adjustments are going to change, and the relationship between the tread pattern is going to sort of take place. So this can be helpful, and I could switch over here if it'd be easier to manipulate this part of the design. I can switch over to this, and you can see how it's affecting both pieces because they're instanced. So I can get that gap just right between these pieces in their relationship, and then when I'm done, I can just get rid of the one piece that I didn't need. So then you'll have your one tread piece all kind of modeled out, and the cool thing is you can just take that. I'll hide my original, rename this tread, snap it to my first segment, and then I'm going to hold down the shift key and then snap it to the next tread segment. Oops, didn't want to do that. This is where it can get a little tricky when you got something kind of overlapping it. So and just for the sake of, usually these are not like perfectly lined up. They could be like slightly offset, something like that. So if I were to take this, my snaps on, hold down the shift key, snap it to that next segment. I know there's 62 of them because I counted them out, so I already have one, so I need 61 more of those. I'll do these as copies. I'll say OK. There's all my tread. All beautifully laid out. Now what I can do is I usually like to go back to one of these is kind of in the middle, which would be, I'm looking at my numbers down here. There's one right at 0, 0. So I usually go back to that one, just because I'm lazy on resetting the pivot, and then have it attach all of the tread pieces. So there's, I don't want to do the plane because that's not a tread piece. So that's why I renamed it too, so I could do this. So I attached multiple, attach them all together, and now they can be bent. 360, that'll get it started. So there's my piece. You'll notice that there is a slight gap in there because it's not perfect, so you tend to have to tweak out the number to get it to be a 1 revolution. And then once you've got your piece, you can just simply align it to your tube. And I will use not the pivot, but I'll use the center of this object to place that. So, okay. Looks like I'm a little off. Am I off by a hair? Maybe I didn't quite get the. Maybe I had one more segment than I should have needed. I should check that. Huh, looks right. Off a little bit. Well, I wish I was a little more spot on with that. I'm not quite sure what I'd have to tweak that out a little bit. Why would that be off? I hate to do it, but I guess I'd have to cheat it in a little bit. I'll do it. That's a lot better. Hide those. So now, ideally, these would be, subdivide very nicely and cleanly. I haven't gone through the steps of, adding additional edge loops and things so that when I subdivide them, they don't get all blobby. But that's more than I can do in this short little video. I was just sort of going over the basic process on how you can sort of accurately model the tire tread onto a tire, and how to use the information that you can get about these tires to kind of get in the ballpark and be sort of accurate to what you're trying to model.